In this video, we're going to take a look at how to evaluate double integrals. In my first example, I have the integral from 0 to 1 and the integral from 0 to 2 of 2x plus 3y dy dx. And we always want to do the inner integral first. So what I generally do is give myself a set of parentheses to know that that's what I'm working on first. And now, so I'm going to carry down the notation for the outside integral, and now I'm going to evaluate this inside integral with respect to y. So here 2x, we're going to treat 2x like a constant, and if we have a constant we add a y on. So we have 2xy plus 3y squared divided by 2 evaluated from 0 to 2. And whenever we're doing double integrals on the first one, I like to write what variable I'm plugging this into so I don't accidentally plug it into the wrong variable. And then dx. So now we need to evaluate the integral, 0 to 1. And remember, we do that by doing top minus bottom. So we'll plug 2 in everywhere there's a y. So I have 2 times x times 2 plus 3 times 2 squared, all divided by 2. And we're going to take that and we're going to subtract by plugging 0 in. And when we plug a 0 in, we have a y in both terms, so both terms go to 0, so it's minus 0. And then dx. So now let's clean this up so we can take the outside integral. 0 to 1. Here we have 4x. And here I have 2 squared, which is 4, times 3 is 12, divided by 2 is 6. So plus 6 dx. And now I'm going to take the integral here. And this is just like the way we did it in chapter 11. So here we're going to have 4x squared divided by 2 plus 6x evaluated from 0 to 1. And now clean this up, say 2x squared plus 6x evaluated from 0 to 1. And now we'll do top minus bottom. So we have 2 times 1 squared plus 6 times 1. And when we plug 0 in, again we have an x in both terms, so it goes to 0, so it's minus 0. And now we add up our terms, so we have 2 times 1 squared is 2 plus 6 is equal to 8. And that is the answer to this double integral. And now let's take a look at another example. In this example I have the integral from 1 to 2, the integral from 0 to 1 of xy plus 2x dx dy. So in this one we're going to do with respect to x first. If you notice, the dx is first, so it's our inner, opposite of the last example we saw. And now when we evaluate the inner integral, we have from 1 to 2 for the outer, and now we're doing it with respect to x, so we have x squared y divided by 2 plus 2x squared divided by 2 evaluated from 0 to 1 dy. And again, it's helpful to write which variable we're plugging this into, so the x variable. And now let's evaluate it. So we have 1 squared times y divided by 2 plus 2 divided by 2 is 1, so we're just plugging in 1 squared dy. And now when we clean this up, we get 1/2 y plus 1 dy. And now we'll take the integral with respect to y. So we have 1/2 y squared divided by 2 plus y evaluated from 1 to 2. So I'm going to clean up my fractions here and say I have 1/4 y squared plus y evaluated from 1 to 2. And now we'll plug in 2 minus 1. So 1/4 times 2 squared plus 2 minus, we have 1/4 times 1 squared plus 1 So on the left side, I have 2 squared is 4 times 1/4 is 1. So I end up with 1 plus 2, or 3 in the first set of parentheses, minus, and here I have 1/4 times 1 squared, which is 1/4 plus 1. So we have 5/4 total in the second set of parentheses. And then if we turn the 3 into 12/4 so we can do the subtraction, minus 5/4. So this double integral's value is 7/4. And that's how we evaluate double integrals.